Hello everyone, this is Abhishek Mohanty and welcome to lecture number 13 of the chapter Electric Charge and Field. Students, in this lecture we'll solve few numericals. So let's get started. So students, look at the first question on the board. The question is two small spheres each having mass m kg and charge q coulomb are suspended from a point by insulating threads each L meter long but of negligible mass. If theta is the angle each thread makes with the vertical when equilibrium has been attained, show that q square is equal to 4 mg L square sin square theta tan theta into 4 pi epsilon naught. So in the question it is given that we have two small spheres each having mass m kg and carrying a charge of q coulomb, means the two spheres are identical spheres, they have the same mass and they carry the same amount of charge. And these two spheres are suspended from a point. So these two spheres are suspended from this point using two threads, and these threads are having a very negligible mass. If theta is the angle each thread makes with the vertical when equilibrium has been attained, show that q square equal to 4 mg L square sin square theta tan theta into 4 pi epsilon naught. So at this position, the two spheres are in equilibrium. It means the resultant force or the net force acting on each sphere is 0. And we have to prove that under equilibrium condition, if theta is the angle between the thread and the vertical, then you have to prove this expression. So let's solve this question. So if the two spheres are in equilibrium, then the net force on each sphere is 0. Now look at the first sphere. So what are the various forces acting on this sphere? The first force is its weight m into g, which is vertically downward. The second force is the tension T along the string. Is that clear? This is the string, so the tension T will act along the string. And this sphere will repel this sphere with a force. So join the two spheres. You have to find what is this distance. Suppose this is sphere A and this is sphere B, and let us say this point is C. So AB is the distance between the two spheres. So to find the electrostatic force on this sphere due to this sphere, we have to find what is the distance AB. It is given that the length of the string is L. The length of this string is L. So if this angle is theta, then this one will be the perpendicular, this one will be the base, and this one will be the hypotenuse. So in this diagram you can see that AC will be L into sin theta. This is P, this is B, this is H. So P by H is equal to sin theta. So P will be equal to H sin theta. And what is H? H is equal to L. So AC will be L sin theta. Similarly, in this triangle, CB will be the same L sin theta, because these two triangles, they are congruent. So CB is also equal to L sin theta. So what will be AB? AB will be AC plus CB, that is equal to 2L sin theta. So the distance between the two spheres under equilibrium condition is 2L sin theta. Now let us resolve the tension force into its rectangular components. So if I draw a line here, a vertical line here, if this angle is theta, then this angle is also theta. Now if you resolve the tension into its components, you will get T cos theta in the vertically upward direction and T sin theta towards right. And again the repulsive force acting on sphere A due to the sphere B will be towards left. This is the electrostatic repulsive force acting on the sphere A. Is that clear? So if you look at the free body diagram, you can see that there are four forces acting on the sphere. Actually there are three forces, but after resolving the tension force, I will get four forces: T cos theta, Fe, T sin theta and mg. And since the net force is 0, it means T cos theta will balance mg and T sin theta will balance Fe. So let me write T sin theta is equal to Fe. Fe means the electrostatic force between the two charged spheres. What is Fe? Fe is 1 by 4 pi epsilon naught Q1 into Q2 means Q into Q divided by AB square. What is AB? AB is 2L sin theta. So AB square will be 2L sin theta whole square. That is equal to how much? 1 by 4 pi epsilon naught Q square by 4L square sin square theta. So T sin theta is equal to this much. This is equation 1. And T cos theta will balance mg. So write T cos theta is equal to mg. This is equation 2. Now let us divide the two equations. T sin theta by T cos theta, that is equal to this much by this one. So T will cancel. Sin theta by cos theta will be tan theta, that is equal to Q square divided by 4 pi epsilon naught. This mg will be multiplied here, so it will be 4 into mg L square sin square theta. That implies Q square is equal to, multiply this denominator on this side, so you will get 4mg L square into sin square theta into tan theta, and here you have 4 pi epsilon naught. So this is the way you can prove this question. So now we will move to the next one. So now look at question number 2. The question is, a particle of mass m and charge minus q enters the region between the two oppositely charged plates, initially moving along x-axis with speed vx. The length of each plate is capital L and a uniform electric field E is maintained between the plates. Show that the vertical deflection of the particle at the far edge of the plate is y equal to QEL square divided by 2mvx square. So let's solve this question. So in the question it is given that we have a charged particle having mass m and it carries a negative charge minus q. It enters into the region between the two oppositely charged plates. Suppose we have two oppositely charged plates like this. Suppose the upper plate is positively charged and the lower plate is negatively charged. So there exists a uniform electric field between the two plates, and we know that the electric field is always directed from the positively charged body to the negatively charged body. So the electric field will be directed in this direction. Is that clear? From positive to negative. And in this region we have uniform electric field, means the strength of electric field intensity is same at every point. The magnitude is same and the direction is also same. So this charged particle whose mass is m and charge is minus q, it enters into this region, and initially it was moving along x-axis. Suppose assume that this is the x-axis, this is the x-axis, and the charged particle whose mass is m and charge is minus q enters into this region. So we know that when a charged particle enters into a region of electric field, it experiences an electrostatic force. So when this charge minus q will enter into this region, there will be an electric force on the negative charge. And we know that a negative charge experiences force in the opposite direction of electric field. Since the electric field is in the downward direction, the force on the charged particle, on this negatively charged particles, will be in the upward direction. Is that clear? But initially the speed of the charged particle was Vx and this Vx was along the x-axis. Is that clear? So there will be two types of motion. When the charged particle enters inside the electric field, there will be two types of motion. The first one is horizontal motion, which is uniform, because there is no force or there is no acceleration acting on the charged particle along x-axis. But there is an electric force, and hence there is an acceleration on the charged particle along the y direction, in the vertically upward direction. So under the action of these two motions, the particle will describe a path like this. The particle will describe a path like this. So we have to prove that, or we have to show that the vertical deflection of the particle at the far edge of the plate. So this is the entry, this is the exit point. So at the far edge of the plate, this is the vertical deflection. Because initially the charged particle was moving along this line, but due to the electric force, it describes a path like this. And at the far edge, it will have some height from this reference line. So this is the vertical deflection, and the symbol is y. We have to prove that the vertical deflection is given by this expression y equal to QE L square by 2m Vx square. What is L? L is the length of each plate. L is the length of each plate. So let's solve this question. So students, remember that the motion along x-axis is uniform. The motion along x-axis is uniform because there is no acceleration, there is no force along x-axis. So Ax is equal to 0. So the uniform velocity along x-axis is equal to Vx. Is that clear? Because the charged particle was initially moving along x-axis with a speed Vx, and that speed will remain the same throughout the motion, that will not change. But initially there was no velocity component along the y-axis. So I can write that the initial vertical velocity means uy is equal to 0, because initially the charged particle was moving along x-axis. So there is no initial vertical component of the velocity. So I can write uy equal to 0. But there is a force along y-axis. The force along y-axis is how much? F equal to QE. I am writing the magnitude of force, that's why I have ignored the negative sign. This is the magnitude of force acting on the charged particle. So what will be the acceleration? The acceleration along y-axis. Acceleration along y-axis will be how much? Ay is equal to, this is Fy, means force along y-axis. Fy by mass, that is equal to QE by m. Is that clear? So this is the acceleration of the charged particle along the y-axis. Now look at the scenario. The charged particle is having two types of motion, horizontal and vertical. And the question is, how long the charged particle will take to reach at the far edge? How much time will the charged particle take to reach at the other end or at the far end? So remember that since here we have two motions, only one motion is responsible to take the charged particle or to help the charged particle to cross this plate, and that motion is the horizontal motion, because this length is along x-axis. So if there is no horizontal motion, only the charged particle will have vertical motion, then the charged particle will move in this direction. But the charged particle is moving in the vertical direction as well as along the horizontal direction, and that horizontal motion is responsible to move the charged particle from this point to this end, or from this end to this end. Now tell me, what is the time taken by the charged particle to cross the plate? So the time taken by the charged particle to cross the plate is how much? T is equal to. So I had told you that the motion along x-axis is responsible to take the charged particle to the other end. The vertical motion is not responsible, because the vertical motion will only take the charged particle in the vertical direction, not along x-axis. So to calculate the time, we have to consider the motion along the x-axis, which is uniform motion, and in case of uniform motion, to calculate the time to cover a certain distance, the formula is time t is equal to the total distance covered, that is L, divided by the uniform speed, which is Vx. So t is equal to L by Vx. Means for this time interval, the charged particle will stay inside the uniform electric field, or inside the two plates, inside the electric field or inside the region between the two plates. And during this time, what is the vertical displacement? During this time, what is the vertical displacement covered by the charged particle? The vertical displacement will be given by this formula, S equal to ut plus half at square, because we know that to calculate the displacement in uniformly accelerated motion, we have to use this formula, S equal to ut plus half at square. Here S is this vertical displacement or vertical deflection. So in place of S, you can write y. And what is u? U is the initial vertical velocity, which is 0. The initial vertical velocity is 0. Remember that when we are calculating the vertical displacement, consider only the vertical motion. Don't consider the horizontal motion, only consider the vertical motion. So in place of S, you can write y. In place of u or uy, you can write 0. So 0 into t will be 0 plus half into a, means the acceleration along y-axis, which is qe by m, into t square. So t is this much, L by Vx. So L by Vx square. That implies y is equal to half q into e into L square by m into Vx square. So we got that y equal to qe L square by 2m Vx square. So we have proved that the vertical displacement is this much, qe L square by 2m Vx square. So in this way you can solve this question. And now we'll proceed to the next one. So now look at question number 3. The question is, an oil drop of 12 excess electrons is held stationary under a constant electric field of 2.55 into 10 to the power 4 volt per meter in Millikan's oil drop experiment. The density of the oil is 1.26 gram per cm cube. Estimate the radius of the drop. So in the question it is given that we have an oil drop, and this oil drop has 12 excess electrons. So students, we know that if a body has excess electrons or less electrons, then it is charged, and when a body has excess electrons, means it is negatively charged. So this oil drop has 12 number of excess electrons, means this oil drop carries a negative charge. And what is the magnitude of negative charge? The magnitude of negative charge is given by n into E, where n is the number of excess electrons. So n is 12, and what is E? E is the charge of electron, but I'll write only the magnitude of the charge. So 12 into 1.6 into 10 to the power minus 19 coulomb. So this is the charge, this is the magnitude of charge carried by this oil drop. And this oil drop is held stationary under the constant electric field whose value is 2.55 into 10 to the power 4 volt per meter. So we know that this oil drop has some mass, and that's why it will be attracted by the gravity with a force m into g. So the force mg or the weight of the oil drop will be vertically downward. But since we have an electric field, and the electric field will exert an electric force on the oil drop, and if the electric force is in the opposite direction of the weight, then there is a chance that this oil drop will be in equilibrium. If the electric force Fe will be equal in magnitude as the weight, then Fe and mg will cancel, and hence the oil drop will be in equilibrium. Is that clear? And since the sphere, this oil drop, carries a negative charge, so the electric field must be in the downward direction. The electric field must be in the downward direction, because we know that a negative charge particle experiences a force in the opposite direction of electric field. Since electric field is downward, the electric force will be in the upward direction. Is that clear? And if this electric force will cancel mg, then the oil drop will be stationary. Is that clear? So in the question it is given that Fe and mg, they have equal magnitude and opposite direction. And what is the electric field? Electric field is 2.55 into 10 to the power 4 volt per meter. So the unit of electric field is Newton per coulomb or volt per meter. And the density of the oil is given, rho is equal to 1.26 gram per cm cube. But remember that we have to always use the SI unit. So the density is given in terms of the CGS unit, gram per cm cube. That's why we have to first convert the density from CGS to SI system. So to convert gram per cm cube to kg per meter cube, what should we do? So 1 gram per cm cube is equal to how much? Kg per meter cube. How much kg per meter cube? Let us find it. So 1 gram means 10 to the power minus 3 kg divided by 1 centimeter cube. 1 centimeter means 10 to the power minus 2 meter, and the power is 3. That is equal to 10 to the power minus 3 kg divided by 10 to the power minus 6 meter cube. That is equal to 10 to the power 3 kg per meter cube. So if you want to convert the density from CGS to SI unit, means to convert the density from gram per cm cube to kg per meter cube, you have to multiply 10 to the power 3. So the density rho is how much? 1.26 into 10 to the power 3 kg per meter cube. So the density is given. We have to estimate or we have to calculate the radius of the drop. Let us assume that r is the radius of the drop. R is the radius of the drop. Then what will be the volume? Volume of the drop will be how much? The drop is spherical in shape, so the volume will be 4 by 3 pi r cube. This is the volume of the drop. So if I multiply volume with density, I will get the mass of the oil drop. So mass of the oil drop will be how much? 4 by 3 pi r cube into rho. Volume into density will give mass. Then look at the condition. The electric force must be equal to the weight, means Q into E is equal to M into G. What is Q? Q is this much, 12 into 1.6 into 10 to the power minus 19 coulomb into electric field is given by this value 2.55 2.55 into 10 to the power 4 volt per meter, and this QE should be equal to the weight, so that the oil drop will be held stationary. So in place of M, you can write this value 4/3 pi means 3.14 into R cube into rho is 1.26 into 10 to the power 3, and then multiply G. This is M, so G will be 9.8. Is that clear? So from this equation you can easily calculate what is the value of R, because here all the values are given except R. So R cube will be how much? R cube will be how much? So bring all these terms to this side. So we'll get 12 into 1.6 into 10 to the power minus 19 coulomb into 2.55 into 10 to the power 4, then into 3/4, and in the denominator you have this 3.14 into 1.26 into 10 to the power 3 into 9.8. So this is the value of R to the power 3. Then what is R? R will be equal to this much whole to the power 1/3. Now you can simplify this expression to calculate the radius. So in this way you can solve this question. And now we'll proceed to the next one. So now look at question number 4. The question is, an electric dipole consists of two opposite charges of magnitude 1.3 into 10 to the power minus 7 coulomb separated by 2 centimeter. The dipole is placed in an external electric field of 3 into 10 to the power 7 Newton per coulomb. What maximum torque does the electric field exert on the dipole? So in the question it is given that we have a dipole having two opposite charges, and the magnitude of charge is how much? 1/3 into 10 to the power minus 7 coulomb. This is the magnitude of either charge, and the separation between the two charges or the dipole length is 2 centimeter. We know that 2a is the dipole length or the separation between the two charges. So 2a is given as 2 centimeter, and we have to convert this to meter. So 2 centimeter is equal to 2 into 10 to the power minus 2 meter. And this dipole is placed in an external electric field having magnitude 3 into 10 to the power 7 Newton per coulomb. So we have to calculate what is the maximum torque exerted by the electric field on the dipole. So we know that inside an electric field, the torque exerted on the electric dipole is given by tau equal to Pe sin theta. Tau equal to Pe sin theta. And when the dipole is placed perpendicular to the electric field, means when theta is equal to pi/2, the dipole experiences maximum torque. And the maximum torque is equal to how much? P into E. If theta equal to pi/2, then sin pi/2 will be 1. And hence the maximum torque will be P into E. And what is P? P is the dipole moment, and the formula for P is Q into 2A and multiply E. So Q is how much? 1/3 into 10 to the power minus 7 coulomb into what is 2A? 2A is 2 centimeter or 2 into 10 to the power minus 2 meter, and then multiply the electric field, which is 3 into 10 to the power 7 Newton per coulomb. Is that clear? So 10 to the power minus 7, 10 to the power plus 7 will cancel, 1/3 and 3 will cancel. So you will get 2 into 10 to the power minus 2 Newton. So this is the maximum, Newton into meter. The unit of torque is Newton into meter. So the maximum torque acting on the dipole is 2 into 10 to the power minus 2 Newton into meter. So in this way you can solve this question. And now we'll proceed to the next and the last question. So now look at the next question, question number 5. The question is, the electric field due to a short dipole at a distance r on its axis is E. If the dipole is rotated through 90 degrees about its center, what will be the new electric field at that point? Suppose we have a short dipole like this. This is minus q charge and this is plus q charge, and this is the axis of the dipole. It is given that the electric field due to a short dipole at a distance r on its axis. Suppose I'll choose a point P here, and this is the center of the dipole O, and the distance of the point P from the point O is r. So this point P is the axial point. It is given that the electric field due to this short dipole at this point P is E. Now, if the dipole is rotated through 90 degree in any direction, you may rotate it in the clockwise or in the anti-clockwise direction. If the dipole is rotated through 90 degree about its center, then what will be the new electric field at that point P? So, if I rotate this dipole, suppose I rotate it in the anti-clockwise direction, then the dipole will be like this. Minus Q will be here and plus Q will be here. Is that clear? The dipole is rotated through an angle of 90 degree. Then what will be the new electric field at that point? So now you can see that when the dipole is rotated through 90 degree, the point P lies on the equatorial line. This is the perpendicular bisector of the dipole. So initially the point P was axial point, and E axial was equal to E. But after rotating the dipole through 90 degree, that point P becomes the equatorial point. And we have to find what is E equatorial. We know that E equatorial is equal to half of E axial, because the expression for the axial electric field is K into 2P by R cube, but E equatorial is equal to K into P by R cube. So you can say that E equatorial is half of E axial. So if E axial is E, then E equatorial will be E by 2. So the answer will be the new electric field at the point P after the dipole is rotated through 90 degree will be E by 2. So in this way you can solve this question. So students, I hope that you have understood all the questions, all the 5 questions that I had discussed in this class. If you have any doubt, then you can ask me in the comment section. And in the next class, we'll discuss about a new topic, that is area vector and electric flux. Till then, have a nice day and bye-bye.